Okay, just want to make sure that everything is sorted out and I am coming through clearly. Audio is up. It sounds like it is. Okay, gonna turn that off. All right, so this is the second week, where I've taken a little bit of time to dig into the Magenta series of real-time music generation models. This is a weekly live stream that I've started as of last week, and I'm basically just taking a couple hours, an hour here and there throughout the week to basically try and study up on and learn a new tool, a new topic, and use some spare time to stay focused on something like that. And the intent here is that as more people discover this group, I'm going to be putting together a meetup for the weeks to come so that there's a little bit more visibility. And people can find it, and it starts to become like a learning sort of study group focused on new and emerging tools. I think just because of my own background, these will generally tend to fall within the space of creative technology, or creative uses of technologies. Oftentimes I am playing around with and testing out, building out different ideas with new machine learning and AI, generative AI tools. So that might often be a focus area, but not always. There's definitely precedence for exploring things like doing a little bit of prototyping work, or even digging back into hardware, and particularly trying to build things. Like a few ideas that I have on the near horizon are like putting together a custom modular MIDI controller, something that has its own sliders and not accelerometers, radial switches, and different controls that I can use to actually mess around with different MIDI parameters and gain levels and stuff while working on audio. So yeah, that's generally the idea here. I'm going to jump over to the demo that I have working. I've continued to do a little bit of refinement on the one I have from last week. So I'll go ahead and turn off this music we got going on in the background here, and go ahead and show what I've been playing around with. So just to contextualize here, we are generally focused this week and the past week on Magenta RealTime, specifically Magenta RealTime 2. I think, yeah, so this one. So it is a real-time music generation transformer, fundamentally. There's three major parts to it. We have SpectraStream, which is an audio codec. We then have Music Coca, which is a text and audio style embedding. And the way to think about that is that we have a lot of audio data, so a lot of free and royalty-free music and songs that were used to then be as labeled data and paired with text descriptions of that music. So you're thinking like many different kinds of genre styles. If you actually look here in the training information that they have, I believe they actually listed some of the music that was used to train. I think it's about 72,000 hours. Where did that actually go here? There's 72,000 hours of music that was actually used to train this model. Maybe if we go here, we'll go into a little bit more of a description. Okay. Anyway, so we have text and audio style embeddings, basically using these short genre descriptions describing different examples of audio that was used to train style embeddings. And then we use a generative transformer, depth former, to generate audio based on those embeddings. You can feed it new prompts and text information. So it actually has the ability to follow prompts that you give it. Go ahead and add this to the stage here. I think I'm not actually sharing my screen. Sorry. So Magenta 2 RealTime. Let's update this. Just do the entire screen. Make sure that I've got audio going. And so we have SpectraStream, Musicoca, and DepthFormer, the generative transformer that we're using to make this, or to generate the audio based on those style embeddings. So I have an example here that I had put together from last week. I'm going to change my prompt type here to something that I know at least has some reasonably decent quality coming out of the small model. They have a smaller one, which is a couple hundred parameters. This large one, I'm generally trying over the past couple weeks. I haven't been able to get this. This is an M4 MacBook Pro Max. So it has 64 gigs of RAM of unified memory. And it hasn't been able to handle using the base model in real time very well. So I'll stick with the small one. It might still not manage to keep enough of a buffer to not skip, but should be able to hear a little bit of audio now coming through. Yeah, so you can hear it's not bad for like 240 params. What we can actually do is also, I managed to get MIDI inputs working. So if I wanted to actually influence the tonality of this, I can add in play notes. Maybe let's change this to something a little bit more melodic. Now we have our keyboard stealing our notes here. So African kalimba. And it should take a few seconds here to transition, but I'll turn that down to 0. And you should be able to hear that start to drift towards the new style inputs that is being given. But I will seems like it's not actually there we go. Okay. As you can see, buffer is going to run out while we're using this base model because it's a lot larger, but I'll switch back over to the small one. Okay, So I was actually able to get that working reasonably well in the background. I mean, the whole intent here is that this is actually a live music performance tool, potentially. So I wanted to try setting this up to actually be usable with live note inputs, not just from a keyboard, but the idea was to be able to either sing a note into it or play in virtual instruments that I have from my laptop here. So like if I have something, I have an instrument here that I can load this out. We'll pause that. I have an instrument here. This is Rolly Studio Player. So I can load different sounds into this. Let's see some favorites that I've got. Polyrhythmic loops. So you can hear the quality there is significantly better. I'll turn that down a little bit so that it's not as extremely loud. Okay, so I have a different demo set up here, and it works similarly, except this one should actually be able to detect microphone audio. I haven't tested the system audio yet, so we'll see if that actually works. So I'll actually start this one. Okay, so we've got that running. I'll enable the mic. So as you can see, it's actually trying to detect notes. And if I sing a note consistently, you should hear it try. Disable input. Oh man. The thing that's really difficult with these is because the sound drifts pretty consistently, because it's only generating a few seconds at a time, it's tricky to get it to really lock into something. So maybe if I do, again, I was showing this last week, but melodic house is it's kind of a consistent one that it has a lot of embedding data for. So I think if we keep style transition. Turn the volume back up on that. Oh, it sounded like it was going to do a build there, and it didn't. Okay, so I'm going to enable the mic again and try and get it to drift towards the tone that I'm going to give it. Yeah, it's. Let's try it. A different note. I think it was just trying there. Oh, it's interesting. It doesn't work that well yet. They say when you actually look at the site for this library that it is intended to be used for live performance. But I'm honestly, we gotta pause that. I'm honestly not, I'm not sure how consistent you would be able to get it. It's something that I think I'm going to continue to play around with, but what I was hoping for when I started to test out Magenta is that I could get a real time, like an improv partner, basically, where you could get it to play a certain kind of music, and just have it go on that track and stay looping in that range. And then you could start playing next to it, and doing something that is paired up with that or harmonizing with it. But I feel like it just the general interaction, um, the actual interface with the model, like you giving it musical feedback, without having to you yourself stop and direct it, is still a little bit wonky. Just giving it pitch data is not quite enough because it's going to try to match what you do. Another way to maybe approach that would be to constrain it to a certain scale, so that it tries to match the actual scale rather than just drifting the entire pitch of the audio, of the music that it's playing. Because then it's really just copying you, which isn't all that interesting. And it's not even doing a very good job of that. Let's try a different thing. So maybe we'll try something that probably also has a lot of audio data in here. So like cinematic synth wave. Whoa, okay. So it's firmly switched over, and you can hear it clearly has an idea of what that might sound like. Okay, so not bad. Let me try to give it some audio direction again via the mic. It might be because the mic is catching some of the sound, but whoa. Yeah, it's clearly trying, but we'll try to reset that again. I'm genuinely impressed by the small model right now. Let's see if I can actually get the system audio. Oh. Well, actually, we're going to have a feedback, well, not an audio feedback loop, but a input feedback loop if I run that right now. What I haven't done on this is actually separated out the audio sources so that I could target like this instrument, for instance. Versus the audio coming out of this app right now. So there's a lot of finagling to be done with this kind of tool right now. And obviously this is just like a demo sort of experiment that I had put together. This one was an attempt to use context capture to actually generate descriptive prompts to influence the music. If I get rid of this, what that was supposed to do is take context from whatever I'm working on right now. But it's still kind of, I think it's generally a little bit inconsistent, and more distracting than something that I would want to have playing in the background. So I think the thing that I would actually be curious to look into, for future weeks that might be focused on sort of creative, or generative audio, or AI augmented music or creative audio would be more in line with creating MIDI notes, not literally generating the audio from scratch, but generating the MIDI guidance for virtual instruments like this one that I have here. Because if you can have an AI that actually, or a generative model that focuses on trying to generate sequences of MIDI rather than the literal audio, I mean, you can hear that. The audio quality is just way better, and it's instantaneous, obviously, because we're not going through using an entire transformer, making all of these tensor calculations and trying to generate 48 kilobit audio from scratch. They claim it's around 200 milliseconds from input to the model being able to change and start to generate what you're guiding it to do. I haven't quite been able to get that working yet. I get a good random prompt here. So like if I try to, still on Kalimba, switch the models over, go to base, and then the small again, and all right, so we have Japanese koto. But let's see if I can actually drive it. It's interesting. It almost seems like because I'm giving it very specific input, that may or may not match up with the embedding information that it is consuming and trying to generate audio from. It almost seems like those signals are fighting with one another a little bit, depending on what music you've got. All right, and then half step down. Yeah, and then half step down. It just gets it gets stuck. It's like it gets bogged down with the input. It's very specific. Yeah. And not necessarily, it seems like it's a different weighted signal in the way that we've actually got this implemented, but just in the embeddings themselves, that are sort of coming from our Musicoca text and audio style embeddings and then running through this generative transformer. So what I want to think about for this next week is, are there tools that could be used to basically try to come up with a similar workflow where you use a local application that is running on a generative model, but maybe that model is not trying to generate the audio itself. Maybe it's trying to generate the MIDI information, and that could be interesting. using something that is then piping that MIDI data to actual instruments and creating a improvisation buddy through that kind of pipeline. There's other topics that I've been interested in looking through. So just to kind of refocus here or broaden out a little bit on the general idea of the weekly stream. Things like text to speech or real-time TTS, not necessarily, I guess, audio to speech or speech to speech, where you're basically just able to interact with a model real time. My general interest here is to try and figure out what kinds of generative tools, generative models are available to get that sort of pipeline running locally, not necessarily using a cloud resource. One of the things I'm doing a lot of right now is running LLMs locally. So I have my own separate laptop device set up to do things like this context capture that I was looking at just a second ago. So this right here is basically it's hitting a, do the drop down here. We're hitting a LM Link remote model that is on a separate device that I have accessible at home, and I have it. It's just an extra laptop, basically. So if you have a spare computer, you can use something like LM Studio and their recent LM Link feature, which they basically allow you to set up that device and have it tunnel through their proxy, and then be reachable from even an iPhone. So you can run open source LLMs, but from your own hardware, and still access them like they are a cloud API, like OpenAI or Anthropic. This one, you can see there's a few different options I have available there, from like Gemma 4 E4B, which is a really small one, to like 26B active 4 billion quantized. So that one is a lot more capable of a model. That would be basically usable as a daily driver for doing coding and software development tasks, doing tool use and running even something like Claude Code, which is pretty heavy. A lot of system prompt context is needed for those kinds of models. But you're able to run something like that on a reasonable piece of hardware and augment whatever types of workflows or projects that you're doing with what is essentially a free a free resource if you already have the laptop laying around. So that is maybe something worth going into in a future session, or digging a little bit more into running local LLM workflows. But in general, I think one of the things that I would like to look into is more audio or speech to speech workflows, where you can run a real-time model, talk to it, have it take that audio, ingest it, process it, and then generate a response and convert that into audio, all in one unified model. There's a few different ones that I've been looking at, but yeah, curious if there are other ideas or interests within the space of generative audio, whether it's for music or it's for controlling audio and music devices like MIDI generation, or in the space of text to speech or speech to speech, like live unified speech models. Yeah, so I'll dig through some of the possible directions for the next week and then post an update for that. And yeah, there'll be another stream next Wednesday, same time, 1 to 2 p.m. And I'll share some notes and resources for that in the GitHub repo. And yeah, hopefully see a few more people around. But anyway, I'll catch you all on the next one.